Hello guys, and once again welcome to the Maths and Science Corner. And today we're going to be doing question 8, which is differential calculus. So without wasting any time, let's just get straight into it. So the first question, we are asked to find the derivative from the first principle. So that is 8.1. So they're saying that we should find the derivative of x squared minus 2. So we know that our formula for finding the derivative from the first principle is the limit as h approaches 0 of f of x plus h minus f of x, right? All over h. So we use this formula to find the derivative from the first principle, right? So we know that, let me just write here, we know that our f of x is equal to x squared minus 2, right? So that means our f of x plus h should be equal to, so where there is x from in this function, we just substitute that with x plus h. So this is x plus h squared minus 2, right? Which is equal to x squared plus 2xh plus h squared minus 2, right? So using this, we can now substitute that into our formula that we have here. So this is equal to the limit as h approaches 0 of what? What is our f of x plus h? That is x squared plus 2xh plus h squared minus 2, right? All of that minus f of x. Here is our f of x, which is x squared minus 2, right? All this over h, right? So then from here, what we do is we say that the limit as h approaches 0. So we can just write this. We try to simplify it. This is x squared plus 2xh plus h squared minus 2. So negative, positive. So this is still negative x squared, negative, negative. So now it's a positive 2, right? All of this over what? All over h. So this is the limit as h approaches 0. So if we look at this, we have x squared and negative x squared. So we can take those out. We have positive 2 and negative 2. So those can go out. So now what are we left with? We are left with 2xh plus h squared all divided by h, right? So what we can do from there is that we can now say the limit as our h approaches 0. We can take the common factor in the numerator. So our common factor is h. So we are left with 2x plus h divided by what? By h, right? So this is equal to what? So now we can stop using this. Oh no, not yet. We can still say the limit as h approaches 0. So these ones are out. H. So we are left with what? 2x plus h, right? So in order for us to stop using this limit as h approaches 0, it is when now we substitute this h into this into this equation, right? Or into this expression. So that would be 2x plus 0, right? Which is equal to just 2x. So this is our derivative from the first principle. And as we can see, if you try to use the power rule here, that is, we bring down the exponent and we subtract 1 from the exponent again. So which is 2 minus 1 is just 1, which we don't have to write it. It's just 2x. The derivative of a constant, which is negative 2, is just 0. So there we have it, right? That would be 2x. So it confirms that our answer is correct. So then we can go to 8.2.1, right? So 8.2.1 says we should find the derivative. This still means derivative. It's just that they're using a different notation. So this is 3x squared minus 4x, right? So how do you find the derivative of this? So we know that if we have a function, if we have d over dx of f of x plus or minus g of x, this is all equal to the derivative of f of x plus the derivative of g of x, right? We know that this is true from the differentiation rules, right? So this is equal to, so we can use that same rule. We can say that this is our f of x and this is our g of x, right? So to find the derivative of this, we just find the derivative of this and derivative of this, then we add them, or then we subtract them in this case, right? So this is 3 multiplied by what? By 2, because we bring down the exponent. Then we say x, subtract 1 from the exponent, we just left with 1. We don't have to write it. Minus 4 multiplied by what? The exponent is 1 multiplied by 1. We don't have to write that. X 1 minus, so this is just x 1 minus 1, which is the same as 0, and which is the same as just 1, right? So we can just leave it like this. So this is equal to 6x minus 4. So that is our derivative for 8.2.1. So now we're going to go to 8.2.3, right? 8.2 point, is it 8.2 or 8.2.2, right? So they're saying what are they saying? They say determine the derivative of g if g of x is that. So let's try to do that. So you see this, they're just using different notations, but they're saying the same thing, right? So the derivative of g of x, if g of x is equal to, they said it is equal to what? Negative 2 root x. So this is negative 2 root x multiplied by x minus 1 squared. So we can't find the derivative of this just like this. We need to try to simplify it, right? So for me to simplify it, I'm going to say negative 2, and this root x, we know that if we have root x, it is equal to what? X to the power 1 over 2, right? X to the power 1 over 2. So I'm going to write my square root of x in that form. So this is x 1 over 2 multiplied by, this is my x squared. If I simplify this, this is x squared minus 2x plus 1, right? So this whole expression is equal to what? We can say negative 2, right? Still unchanged. So we have our x to the power 1 over 2. We know that if the same basis, we add the exponent, right? So this is plus 2. Then now we go to the next term, negative 2 multiplied by negative 2, that's positive 4. And x 1 over 2, add the exponent, plus 1, right? Then we say we go to the last one, multiplied by 1 is still going to be itself. So this is just negative 2 x 1 over 2, right? So all of this is equal to what? This is negative 2 x to the power 1 over 2, that is 2 plus half, which is 2.5, which is just 5 over 2, right? Then plus 4 multiplied by x 1 over 2 plus 1 is what? That is 1.5, which is 3 over 2, right? Minus 2x 1 over 2. So this is just g of x. We haven't found the derivative right yet. We haven't computed the derivative yet. So to find the derivative, we're just going to use what? The power rule, right? So we say -2, that is like our k, our constant. So multiplied by the exponent, which is 5/2, multiplied by x, 5/2 minus 1. What is that? That is just minus 1. That is 3/2, right? 3/2. 5/2, yeah, that should be 3/2. If we're subtracting 1 plus 4 multiplied by the exponent, which is 3/2, x, 3/2 minus 1, that should be 1/2, right? Minus 2 multiplied by 1/2, then x, 1/2 minus 1, that is negative 1/2, right? Let me just check here. 5/2, 5/2 is 2.5. 2.5 minus 1, that is 1.5, which is 1.5 is 3/2. Okay, we are good, right? So now this is our derivative. So we can just simplify this whole thing. You can see that we have a 2 and a 2 in the denominator. So that is out. This is, so we are just left with what? With -5, -5x 3/2, right? Plus 4 divided by 2, that's 2. 2 times 3, that's 6. So this is 6x 1/2, right? Then minus 2, they cancel, they go out. So just left with 1. So that is x -1/2, right? So I hope you all are good. So if there's any mistake that I made here, please do not hesitate to say it in the comments so that we can fix it and not mislead people, right? So yeah, from that we can go to 8.3, straight to 8.3 if there's no problem. So 8.3 says what? Says given that y is equal to 4 plus 14, so given is it minus 14 or positive 14? Oh, so it's minus, is a common tangent to 2x squared, okay, is a common tangent to x squared what? Minus 4x minus 6. Minus 4x minus 6. And g of x is equal to ax squared, if I'm not mistaken, plus bx minus 18, right? Calculate the values of a and b. So they want a and b, right? So what we can do here is that we can try to use our knowledge about tangents and gradients, right? The tangent at a point, what is the relationship about the gradients and the x values and the y values, all of that, right? So we know that if a function, let's say, for example, how can I put this? If we say maybe we had something like this, right? Let me draw a function here. If we had something like this, right? And we had another function here moving like this, maybe just touching at one point, right? It's touching at one point. We know that at this point, these two graphs or these two functions, they share the coordinates, right? We know that they share the coordinates. They have the same x value and y value, right? So we're gonna use that thing, and we know that they also have what? Same gradient at that point, right? So those two things, those two information are going to be our tools in this question, right? So what we can do, the first thing is that we know that they share the y values at this point. We know that this function and this function and this function share the y values, right? So we can just say that y, this function, which is 4x minus 14, is equal to f, which is 2x squared minus 4x minus 6, right? And if we try to simplify that, you can say 2x squared minus 4x and minus 4x again. So I'm just taking everything to that side, right? So minus 6, this is the minus 6. Then we take the negative 14 to that side, it's going to be positive 14, right? And all of that equal to 0. So we have 2x squared minus 8x and plus negative 6 plus 14, that's 8, if I'm not mistaken. That is equal to 0, right? So now we have a common factor 2. Can take that out. We are left with 2x with x squared minus 4x plus 4. That is equal to 0, right? So that means x squared minus 4x plus 4 is equal to 0, right? So now if you try to simplify this, we have x is 0. So this is x minus 2, right? So basically our x is equal to 2. So that is our x value at that is the x value that this tangent line and this function share, right? The tangent line, this one, and this function share, right? But we also know that they also share it with g. So first of all, let's try to find the y value. We can use any equation. We can use either this one or this one. So I prefer to use the linear one because I feel like it's much more simple. Therefore, our y is 4. Our x is 2 minus 14, right? So we have, that is 8 minus 14. That should be equal to negative 6, right? So if that is equal to negative 6, therefore we have y equal to negative 6, which means that we now have what? We have our x value and our y value, right? But we know that they also share these values with g. So we know that g of x is also equal to negative 6 at that point of tangency, right? Not just anywhere, at that point of tangency. So we also know that this is not just g, but it's g of 2, right? Is equal to negative 6. So what is our g of 2? If we sub in 2 into that equation, we have a 2 squared, right, plus b multiplied by 2 minus 18 is equal to negative 6, right? So this is 4a plus 2b minus 18 plus 6. If we bring the 6 to this side, then all of that is equal to 0, right? So this is 4a plus 2b negative, this is negative 12. Negative 18 plus 6 is negative 12. All of that equal to 0, right? So if we divide everything by 2 here, we're going to have 2a plus b minus 6 is equal to 0. So this is our equation 1, right? We're going to come back to this equation. So the other property that we said we know from this, we said that we know that they, at this point where this all these curves touch, we know that they have the same gradient at that point. And we know, okay, from the tangent line, we know that, okay, we know its gradient. Its gradient is what? 4. So if we know the gradient, we might use that information as well. So we know that, okay, g of x, how can we express the gradient of g of x? We can say the derivative, because we know the derivative of a function also represents its what? Its gradient at a point. So the gradient at a point here, it should be equal to what? To 4 at this point. At which point? When x is 2. So this is right. So this is what we have. So from this, what can we say now? We can say that the g prime of 2, which is g prime is what? You can say we're just going to derive this, right? This function, go to derive it. So that is 2ax. So this is 2, let me just write that this is 2ax what? Plus b is equal to, because okay, we have negative 18, if we derive that, that's 0. So this is equal to 0, right? Therefore we have what? We know that we evaluating this at 2. So this is 2 multiplied by 2, which is 4a plus b. Oh no, this is not equal to 0. I made a mistake here. This is not equal to 0. It is equal to 4, right? So this is our equation 2, right? So therefore b is equal to 4 minus 4a, equation 3. So now we can just do what? Sub in 3 into 1, right? So that we can, this is just like solving simultaneous equations, right? So we have 2a plus b, which is 4 minus 4a, and minus 6, that should be equal to 0. So 2a minus 4a, that should be negative, what? I feel like I made a mistake somewhere. Let me check. Okay, there's no mistake. Let's see. This is negative 2a. 4 minus 6, that is what? 4 minus 6, that is negative 2, equal to 0. Therefore our a is equal to negative 1, right? If we take this 2 to the other side, divide both sides by negative 2, our a should be equal to negative 1, which means from this now we can now say what? Our b is equal to 4 minus 4, negative 1, which is b is equal to 4 plus 4, which is 8.